one thing I'd like to add here quickly before we move on. One thing to note is that constants are also considered like terms. Constants are like terms. So before we get into actually adding and subtracting like terms, let's go ahead and just do a little bit more practice with determining if things are like terms or not. So looking at the first one, it says r3x squared, or we have 3x squared and we have negative 37x squared. And I actually already told you that they are in fact like terms. So let's discuss why are they like terms. Well, first off, remember to be like terms, they have to have the same variable raised to the same exponent. So looking here, 3x squared and negative 37x squared, they both have the same variable. That variable is x. And what is the exponent for both of those x's? Well, it's an exponent of 2. That little number is 2. If you have the same variable and the same exponent for that variable, then they're considered like terms. On this one, however, I said that we have 5x and 6y, and I said that they are not like terms, meaning we could not add them or subtract them from each other. The reason why they are not like terms is because they have different variables. The first one has a variable of x, and the second one has a variable of y. They don't have the same variables, they are not like terms. Even though we know that the variables are different, let's just check the exponents. Well, the exponent for 5x, the x just has an exponent of 1. Again, if there's nothing there, we assume it's a 1. Same thing with the y. It has no exponent there, so we can assume that is a 1. So it meets one of the two qualifications or requirements in order for them to be considered like terms. They have that same exponent, but they do not have the same variable. Finally, this last one, again, these are not like terms. This one, like our previous one, it's going to satisfy one of those qualifications, but not both. The one that it satisfies is the variable part, right? Because they both have a variable of x, right? That's the letter we see there. However, if we look at the exponents, this first one has an exponent of 1, and the second one has an exponent of 2. So since the exponents are not the same, they are not considered like terms. Again, variable and exponent must be the same. So let's jump into some examples of combining like terms. Some things that I like to do to indicate that things are like terms, sometimes I like to use different shapes. So maybe I'll put squares around things that are like terms, or triangles, or circles, and so on. Or I might use different colors. Again, this just helps me stay organized in my work. So notice this first one I did it for us, right? I put my like terms in different shapes. So if I look first here at this 6x, which I put in a square, notice I said, well, the 6x can combine with this negative x, right? Because they're both the same variable, they're both x's raised to that first power. I always, when I make my shapes around things, I always want to include the symbol that's right in front of that variable. So for instance there, I can think of that as like a negative x. So here to combine these terms, I take 6x minus x, which is like minus 1x. So if I have 6 of something and I take 1 away, that's going to leave me with 5x. Next here in my triangle, I did a negative x squared. We couldn't have combined this with the 6x and negative x because it did not have, or the x squared has a variable of 2 and those other x's did not. But I can take this negative x squared and I can combine it with, and I'm just going to include that sign right in front of it, is positive 4x squared. So I have a negative 1x squared plus 4x squared. So negative 1 plus 4 gives me a positive 3x squared. And then lastly, we have our constants left over, right? Numbers without variables. So I have a positive 3 and a negative 2. So 3 minus 2 gives me a positive 1. So that is how I would simplify my expression by combining like terms. All right, let's do another one together. We're going to do a few more, and then I'll let you try some on your own. So on this particular problem, again, we want to combine like terms. I like to look at the first term I come across. So I'm just going to start with a square around 8x. Again, I just use shapes so I can determine what things are like terms and I can group them. So I got to think about what things can I combine with an 8x. Sometimes it might be one thing, sometimes it might be multiple things, sometimes it might be nothing. So if I'm looking here, I have this 8x. I can't combine the 9 with it because it doesn't have an x. The 2x squared does not work because the exponents are different. I can't do the 1, but I can in fact do this x here. Again, I'm boxing in the symbol that goes right before it. So I know that I have 8x plus x, so that's going to give me 9 x's. My coefficient changes to 9. Next, I come across this negative 9. This is a constant, so I got to look for another constant to combine it with, which is going to be this plus 1. So negative 9 plus 1 is a negative 8. And then lastly, I come across this 2x squared. It's positive, and I can combine it with this negative 6x squared. So I have 2x squared minus 6x squared, so that's going to give me a negative 4x squared. So here's my simplified expression. One thing to notice, and I would probably write this down because I see this happen too often on homework and assessments, I would write notice exponents and variables do not change when combining like terms. Right, so all of a sudden my x's don't change to y's, my x squared doesn't change to an x cubed, right? They stay the same. The only thing that changes are those coefficients out front, those numbers in front of my variables. Alright, so a lot of times in math they're going to say write an expression in simplified form. What that means is they don't want to have any like terms that are not combined, and they don't like to see any parentheses. If they see those two things, they would consider that expression not simplified. So here's an expression that would not be in simplified form. So there's kind of two ways you can do it, right? You can start by getting rid of the parentheses first, or you can start by combining like terms first. I generally always like to get rid of those parentheses first. And we know this from yesterday, to get rid of the parentheses, we have to go ahead and do the distributive property. So the distributive property says I first have to take 2 times 3x, which gives me 6x. I then have to take 2 times a negative 5, so that's going to give me a negative 10. And then 2 times 4x, so that's going to give me 8x. You may be thinking, well, based on yesterday's homework and notes, we would have been done at this point. But based on what we know today, we are not done. Right? We said we can't have parentheses and we can't have like terms. Well, I noticed here I have a 6x and I have a positive 8x, and those two things are like terms because they have the same variable raised to the same power of 1. So when I combine those, 6x plus 8x is going to give me 14x. There is nothing that we can combine this negative 10 with. It has no buddies, so it just has to stay as a negative 10. So there would be my expression in simplified form. All right, so what I would like you to do at this point, there are 2 examples on this page, and then there's 4 on the slide after that. I'd like you to try these problems for me, please. The sub's going to pause the video at this point. Once you've had about 5 minutes to try them, the sub will turn it back on, and you can check your answers. All right, we're just going to go ahead and check our answers here real quick. On this first one, you should have seen that they were like terms, so you would have gotten 10x squared. On the second one, I kind of put shapes around the like terms. The 5x and the negative 3x, you can combine to 2x. The negative 3 and the positive 4, you can combine together to get a positive 1. And then lastly, that 6y you cannot combine with anything because there's no other terms that just have y as a variable. Looking at this second page, the top one, you have 3y minus y. Remember, if there's no coefficient explicitly written there, we know it's a 1. So it's 3y minus 1y. So 3 take away 1 is 2. So you're left with 2y. Looking at this second one here, we check, do they have the same variables? Yep, they both have an m and an n, and both of their n's are raised to the 4th power. So those are considered like terms. So we take negative 7 minus 5. That gives us a negative 12. My variables and exponents do not change when I combine like terms, so it's still an mn to the 4th. These bottom ones I want to talk about because in previous years these have been kind of confusing. Or these are the ones that maybe some mistakes happened on. So if we want to determine if things are like terms, we have to see if they have the same variable raised to the same power. Well, all three of these terms have the same variables, right? They both have a y and a z. So you might be thinking, well, I can combine all of them. However, that's not the case because if we look at this first term, we see that the y is raised to the 3rd power and the z is raised to the 1st. If I look at the second term, y is raised to the 1st, z is to the 3rd. So that means I cannot combine those, right? They're not the same powers for those variables. However, this last one, y to the 3rd and z, that's the same as my first term. So those two we can combine together. So I have 7 plus 1. So I get 8 y to the 3rd z. There's nothing I can combine with this middle term because none of them have the same variables as that middle term. So I have negative 6yz to the 3rd. And this last one here, a little bit confusing. Maybe because you'd be thinking, well, they have the same variables, a, b, a, b, a, b. Okay, but we have to check exponents. So if I look at this first term, do any of the a's have an exponent of 1 and b's an exponent of 2? Not in any of those last two terms. So there's nothing I can combine with the first term. Well, the middle term has just an a and a b. Does this last term have just an a and a b raised to those first powers? No, the a is raised to a 2nd power. So technically in this last problem, there are no like terms. So if you come across a problem like this on your homework on the quiz, you would just go ahead and circle it because there is nothing there that you can combine. Hopefully by this point you're feeling pretty confident with combining like terms. Again, just the big thing to remember, in order for two terms to be considered like terms, they have to have the same variable or variables, and those variables have to be raised to that same power. Tomorrow we'll go over any questions you have. Good luck on your homework. If you have any questions on your homework, feel free to shoot me an email. We're not going to do the last problem on the notes just for the sake of time. All right, thanks and have a great day.